Alright, so no one's watching, so I'm just talking to myself. Um, I don't know, that would be interesting if, like, I make a really cool engine and I publicly broadcast it, but nobody sees. Or I just suck. One of those things. Anyways, everything I did in the last video is fucking bullshit. Complete fucking bullshit. Like these variables here. That's this right here. That and this and that. Bullshit. Complete bullshit. Like this whole diagram, like from this, section here, starting here, all the way up to here, like this stuff. Bullshit. It's absolute bullshit. And I'll show you why it's bullshit. Well, first of all, let's open that bullshit diagram. So the map tile SP diagram is bullshit. So let's open that up. What the fuck? Oh. Sorry, hold on. Wrong shortcut, but I want to just make a note here. Let's just use this. So this is bullshit. Complete bullshit. Okay, so all this stuff, all this hunch I have, all this mathematical intuition, complete bullshit. I don't have mathematical intuition because it's wrong. So the thing is, I'm thinking, okay, a tile whose side length is 5 pixels wide has valid coordinate values of, 0, 1, 2, 3, and 4, but not including 5, right? The last coordinate is not inclusive. So I'm like, okay, so 0 to 5, not including 5, step of 1. That's kind of what I'm thinking there. And I'm like, okay, so then it would be like, if we have 0 to some variable, and going with this same pattern up here, okay, 0 to some variable, not including that variable, step of, what the fuck is the step, right? That's kind of the pattern I'm looking at. Well, then I'm like, wait a second, so then I'm, thinking here, and I'm like, okay, well, if it's 5, what the fuck's long, right? And so the range would be 0 to 4, what the fuck's, right? Like, well, how do we know what these subdivisions here are? And then I thought about it, and then I thought about it, and then I'm like, what the fuck? The units are always pixels. The units are still pixels, even if it's a range where it's a fraction, right? Where something's 5.5 pixels wide or 4.5 pixels wide. That doesn't change anything. That doesn't mean you need to do some weird offset. Look here. So here's my stupid mathematical proof that's not really a proof. Think about this. Okay, if your tile is 64 pixels wide, right, then the range is 0 to 64 minus 1 because you start counting at 0, right? So the first coordinate is 0. Okay, if it's 8 wide, so much less than 64, the range is 0 to 8 minus 1 because you start counting at 0. Now if it's somewhere in the middle, 8.8, well, the range is 0 to 8.8 minus 1, okay? The fact that this is fractional does not change the fact that to make the proper range, all you have to do is go minus 1, right? So this whole idea here, where I'm like, oh, this isn't minus 1, this is minus some fucking fraction that's like the ratio of the source and destination viewports, complete bullshit, not true, okay? These values here are 1. That is the fact of the matter. Now, the problem where we're getting an error showing up in our code that we have to fix or somehow figure out how we're going to accommodate it is that when you have you're scanning through all the pixels on the viewport, okay? But if a rectangular region on the destination viewport is some type of fractional width or fractional height, then you will end up with pixels that belong simultaneously to two tiles, right? If it lies on that border. Or you could have it simultaneously belong to four tiles at the same time if it lies on like the corner border of a of tiles, right? Never to three though, right? Because there's no fucking way you could get like a square to like sit in three borders, but not the fourth, right? Um, so with that, you'd have to figure out some type of like sub-pixel anti-aliasing type algorithm if you really wanted to like make that all nice and not get any like anti-aliasing artifacts. I don't care about that right now though. The way I'm probably gonna fix that issue, if I really run into that issue, is I'll just use something called super sampling, which is kind of expensive, but I don't know, it makes things easier. Where you just you always have everything scaled up so that everything that is rendered goes in evenly, and there's no like sub-pixel trickery going on. There's no like fractional pixels or any weird stuff. Everything just goes in evenly because of whatever size you've rendered it to, which is like a bigger size than the final size in the viewport. And then once you've rendered it out off screen somewhere, you kind of like shrink it back down to fit into the viewport, and then you solve the problem of having a pixel that lies simultaneously in two tiles at the same time. But yeah, so that was complete bullshit, and now I have to go and fix my bullshit. So this little check here, this check, complete bullshit. This thing where I'm like, you know, postulating here, it's wrong. Yeah, I just gotta get rid of that. Okay. And then we gotta go and find this scaled pixel stuff, like, that I was thinking about. Complete bullshit. All of it. All of it. Just take it all, and throw it in the trash. Because it's wrong. Okay. So now that we've gutted that, basically, we still have to think about, we were making calculations, and we had some modulus by fractional values that was still kind of dangerous. And let's go find where that was going on, right? Because we kind of fixed that, right? We like probably used this local coordinate here to solve something or other. Yeah, modulating by fractions, asking for trouble. So this right here, right? So we did decide that we were going to fix that by taking the local destination viewport X and local destination viewport Y, and then we take the width and height of a single tile on the destination viewport, right? So if we look at TP, so this was tile pixels viewport 0, and let me see if I have. Let me take that for a second, see if I've documented that yet. So if I go TP0 width like that, dash means, and I, okay, TP0 width, tile size in pixels, viewport 0, aka destination, and it's the width. So yes, that is what this variable means. So all this math right here, I'm pretty sure it's correct. The problem you can run into, like I said, is that a pixel could end up simultaneously belonging to two tiles at the same time when you get these fractional borders, because the tile size on the destination canvas is fractional. So we gotta... Let's see, so what's this? The width. So LDX is... so now the question is... LDX is definitely a tile value, right? Because it's... It's a pixel value, but it's been made local. So there's definitely a possibility that this could end up out of bounds if and when I had the idea of sealing things, right, to see if anything is well, let's just give it a run. Let's give this all a run again. And just see what happens, because I know one of these errors is going to get caught, but we can address it and actually fix the problem this time. So so LDY, and can we clear the console here? What the fuck is this? Why do I have two of these? Because so if we take this, we're gonna put that there. We're gonna put a breakpoint there as well, and let's just refresh. Can we refresh? And we're at this breakpoint. Okay. So these coordinates, is that, yeah, these coordinates here, right? So it's because this coordinate is an actual pixel on the destination viewport, and the pixel values can only be whole values, right? So 4 is 4 within this. Yeah, it is within the 3.5, right? It's partially within the tile, but not completely within the tile, but it's still in there, right? So in order to fix this, to like make sure that we account for this problem here, is we could take this value and we can seal it, right? And then if oh no, we're not sealing it. My bad. Well, maybe. So what's the best way here? Because if we seal this, right, then this is still less than, but we're also doing. So this is the. So this is the min and max value, right? So if we do seal this, then this would be valid. This would now be in a valid range. So, okay, yeah. So if we seal this, but we're not gonna. What we're gonna do is, in the throw area, we could seal this, right? So we can. So let's go over here for a second. Where we throw it, right? We could say else, and then if math dot seal, right, and then so this value here, and then we'll say that less than or equal to. And so this is just like else. So now we're absolutely out of bounds here now. But if we're in here in this section, we have a pixel that kind of belongs to two tiles simultaneously. And I don't know if there's a equivalent for the lower bound. I think there is, but I don't know what that would be. Well, I think we'll probably find that out, right? Like, if we find something that's slightly, I don't know, maybe slightly negative, that could be indicative of, like, because if this pixel is halfway inside the tile, then that must mean that it has like a right, it's halfway inside of two different tiles, right? So you would think that it would throw a out of bounds positive for one iteration, and then for another iteration the same pixel would throw like a negative out of bounds, but maybe not. We're not going to be too concerned with that. We'll address it if we find a problem. But so also if it's greater than or equal to 0, var max equals math.ceil. Okay, so I'm just gonna make this into max because I just this fucking shit, when it gets this long, it just annoys the hell out of me. Okay, we could say min. Sure, why not? Why not be consistent, right? So, if x is greater than or equal to min, or less than or equal to this max, which has been modified by ceil, then we're still gonna do nothing. But hold on there. But it is kind of like between cells, so I almost feel like we should have like the RGB ref equals like RGB gray or something like that. Like partially on two different tiles, something like that. And then we could do the same thing where let's take this logic, and we'll just take it all. Actually, so let's take all this logic, and then we can paste it into the LDY OOB, which is not really LDY anymore, is it? No, it's not. What the fuck? Okay. So, this is... right, and this is... yeah, so this is the value we're checking to see if it's out of bounds. So let's modify the y here. Right, change that, control 0, because these should be different values now. Right, OY, and then if we highlight this, okay, let's take another look at this. Well, this is the part that's changed. So if the y is greater than or equal to min, and it's less than or equal to the max, and max has been ceiled, and min is just 0, and then we'll change it to gray if it's like partially on two different tiles to get kind of like a hackish anti-aliasing effect. And the thing is I don't actually have anything called RGB gray, so we gotta go up, and find where we would find like RGB black, and make another variable that kind of holds those byte values for a black pixel. And it's like, where the hell? There's just so much stuff here that now it's getting hard to. So var RGB gray. And that equals I don't know, like 128 128 128, and then just 255. Okay, so RGB gray, we have the variable for that. And we set it here and here, and that's just gonna like try to get we can give this like a more advanced treatment later, but that's just what we're going to do for now. And we're going to give this a run and hope that we have something going here for us, because it's getting annoying. And I did not start a timer, so I don't know how long I've been going. So I'll probably okay, so out of bounds and out of bounds. So we're still getting out of bounds problems. Okay, so what do we got? Y 4.4 and the max is 4. Okay, yeah, so that's a fucking problem, isn't it? Because we've taken it. Would it be more like... Well, if it's possibly 1 pixel out of bounds... Oh, what? Oh, wait. Huh? Okay, here's my thought. Maybe it's this value, and then we add 1, and then we seal it, you know? And if we're still getting a problem, then there's definitely something worse going on. But let's just be a little bit more generous with this. And I'm going to stop recording because I didn't start recording a timer, so